Okay, hi class. So we're back at it, doing 7.4, close to the end of all the different types of identities that we'll learn. And so these ones are about sum to product and product to sums. And what that means is that a lot of times we have these really cool symmetries where, I'll grab my pen here. When you have cosine times cosine, we can reduce it back into the sum formula. So this is sort of going backwards of what we learned about last time, in video 7.2 about the sums to products. So this is called the opposite. This is product to sum. So when you have cosine times cosine, it splits up into this. And same thing with sine times sine. It splits into this, and vice versa. They split up into their constituent parts. And again, this is these formulas are kind of a doozy to have to remember, so I don't require you to remember them, just to know how to use them. I'll provide this for you on the exam and our formula sheet, a little cheat sheet we have for this test, this chapter. Okay, so let's go ahead and take a look. So it looks like this is going to be a cosine times a cosine, so I'm going to be right here. This is my alpha. My alpha is 3 theta. This is my beta, so my beta is 5 theta. And so then I just plug it into the formula. So this is going to equal 1/2. The 1/2 is there in the formula, so it's just 1/2 times cosine of alpha minus beta, so it's 3 theta minus 5 theta. Again, it's alpha minus beta. And then it's going to be plus cosine of 3 theta plus 5 theta. Okay, and so that's just using the formula. And of course, these are like terms now, so this becomes 1/2 times cosine of 3 minus 5 is negative 2 theta plus cosine of 3 plus 5 is 8 theta. Okay, and we could leave it like that, except I'm going to use one more identity, which is I know that cosine is even, so this negative doesn't matter at all. And so for cosine here, this will just become the same thing as cosine of positive 2 theta plus cosine of 8 theta. Okay, and that is it for the answer right there. Alright, and so that was just kind of just getting practice with it, but in reality we usually like to use it when we have these non-standard angles. So I have a cosine times a cosine here, so let's call this alpha. So alpha is 11 pi over 12, and beta is pi over 12. And so then we just go ahead and apply the formula. So it's going to equal 1/2 times cosine is alpha minus beta, so it's going to be 11 pi over 12 minus pi over 12 plus cosine of beta, alpha plus beta, so 11 pi over 12 plus pi over 12. Okay, and now we can just combine 11 minus 1 gives me 10 pi over 12. And 11 plus 1 gives me 12 pi over 12. Okay, and I'm just doing piece by piece. You don't have to go this slow when you do it. You can jump right ahead to here, which is 10 over 12 is 5 pi over 6. 12 over 12 is 1, so this just becomes cosine of pi. Okay, and then we can evaluate these, because now this is a standard angle. 5 pi over 6 and pi, those are on the unit circle, the angles that we know. So 5 pi over 6 is over here, and so that is the bigger, x is bigger, so it's negative root 3 over 2. Cosine is negative over here. And so that's 5 pi over 6. And this whole thing is pi, and that's negative 1 comma 0. And so we get 1/2 times cosine of 5 pi over 6 was the x value, so it's negative root 3 over 2. I didn't need that there, so forget that negatives. Let's forget that parentheses. Plus cosine of pi, which is negative 1. we can write them, I guess. And so that gives me 1/2 times, you can get a common denominator, you don't have to, but it would be -√3 minus 2 all over 2. And you get that. Like that. So I just got a common denominator right there. Okay, so that's that. Now you can also distribute, I guess, the 2's here, so it becomes -√3 minus √2 over 4. I guess that would be the best answer, because I got to distribute that too. Okay, so those are the formulas. I only did the cosines, but the sines and the mixes here, they're all basically the same. So just make sure you apply it, identify your alpha and beta, and then just go ahead and go from the formula there. So moving backwards is called the sum to product formulas. Now this is when you have a sine plus a sine. So these are not in the same sign. These are two different terms here. I have two sines, or two cosines, or a sine and a cosine. So the way this works is that if you have an alpha, sine of alpha plus sine of beta, it ends up being this. And this 2 is in the formula, so it's always going to be times 2. This 2 is also in the formula, it's divided by 2. And then you just have these sums, or these differences here. So let's take a look. So write the following as a product. Sine of 4 theta minus sine of 2 theta. So this is a difference of signs, so we're going to use this formula. This tells me that my alpha is 4 theta, and this tells me my beta is 2 theta. So then I just apply the formula, and you get 2 sine, and the way the formula works is that it's alpha minus beta, so it's 4 theta minus beta, so minus 2 theta, all over 2. And then minus, sorry, not minus. So the formula then has, you get divided by 2, then you multiply it by cosine. So multiply by cosine of alpha plus beta, so 4 theta plus 2 theta, all divided by 2. Okay, and then you get 2, okay, then we can just kind of finish this out. 4 theta minus 2 theta is 2 theta, so 2 theta over 2 times cosine 4 theta plus 2 theta, so 6 theta over 2, over 2, and then we can go ahead and finish out. Now these 2's cancel, 2 sine theta, and 6 divided by 2 is 3. So that's it. So just identify your alpha, identify your beta, and then just apply the formula. I applied this formula because it was a sine minus a sine. Okay. And let's do ones with actual angles here. So, so that's going to be my alpha, and that's going to be my beta. And I want the difference of cosines, so I'm going to be using this formula, cosine minus cosine. And so that says it's going to be equal to -2 sine of alpha plus beta, so 15 degrees plus 75 degrees, all over 2, times sine of alpha minus beta, so 15 degrees minus 75 degrees, all over 2. Okay, 15 minus, yep, that's right. And we can simplify that, so it's going to be -2. And remember, the -2 here is just from the formula. It's just in the formula. Same thing with the reason we're dividing by 2. And so we combine these. So 15 plus 75 is 90. So you get 90 degrees divided by 2. And then 15 minus 75, that's -60. -60 degrees over 2. And so that tells me it's -2, finishing up here, 90 divided by 2 is 45 degrees, and sine, that's -30, sine of -30. Okay, and then you just draw your unit circle here, and you know that 45 degrees is right here, so that's √2 over 2. We want the y value. And at -30 is down here. It's the smaller angle, and so that's -1/2 √3 over 2. But I just care about the y value right there. So that tells me that this thing is equal to -2 times sine of 45 is root 2 over 2 times sine of -30, which was -half. Okay, and that tells me it's equal to, so these can cancel, and it's going to be, and these can cancel, and so it just becomes positive, so forget that, it becomes positive root 2 over 2. Like that. Okay. So there you go. So that's interesting. I didn't know that. So if I did that, cosine, let me put my in degree mode. It's kind of cool. So that's the same thing as just cosine of 45. So cosine of 15 minus cosine of 75, root 2 over 2. Well, I'll be darned. Oops. Root 2 divided by 2. Right there. Wow, that's pretty cool. Math is always full of intricacies and mysteries. Okay, so let's do this one. We can then again use this to help us prove an identity. So this one I have a difference of cosines. So this is my alpha on the top, and this is my beta right here. And so it's cosine minus cosine. Okay, just like the one we did right here. So that's equal to, so let's work on the top. So the top is going to be -2 sine of alpha plus beta, so 4t plus 2t, all over 2, and then times sine of 4t minus 2t, all over 2. Okay, so that's the top. The bottom, well, that's going to be, oh shoot, that was just a, no, that's right. So here this is a addition of sines. So here my alpha is 4t, my beta is 2t. So the addition of sines, oops, right here, don't die on me, computer, sine plus sine is right here. And so that's 2 times sine cosine. So it's 2 times sine, we add them, 4t plus 2t over 2, times cosine of their difference, 4t minus 2t, all over 2. Again, I was just using that formula right here. Oops. Formula right there. Okay, so these cancel, and so I'm left with negative, and this is 4 plus 2 is 6, so sine of 6t over 2 times sine of 2t over 2. I feel funny saying that, 2t, sounds weird. Okay, then we get sine of 6t over 2 times cosine 4 minus 2 is 2t over 2. Right, and so we're left with negative sine of 3t times sine of t, sine of 3t cosine of t. And so these cancel, they're the same term. And so I'm left with negative sine over cosine. And they're the same thing. So sine over cosine is tangent, so it's negative tangent. Okay, and that was the right-hand side. So we started with the left-hand side, and we ended with the right-hand side, which is the whole goal of doing identity. Okay, so that's it. So pretty straightforward. Again, just these 8 identities just kind of come along anytime you have a sum or addition or anything like that. Then we want to turn a product into a sum or vice versa. So you don't have to memorize them. I'll provide them for you, and just go ahead and get practice on working on them. All right, thanks. See you in the next video.